Here's the last type of function we need to work with. We need to work with square root functions right here. If you were to see this function, it's the parent function of the square root function, which is y equals the square root of x. And we're going to figure out how this function changes if we multiply it by something in the front. That's going to be this a. If we do something inside, subtract something from underneath the radical, that's what this h is. And if we add or subtract something on the outside, that's what this k is. We're going to see if we get same or different results from before. So let's just go over to my graph of this and see what we get. Here's my square root function right here, and we're going to just toy around with this. Let's start with the k and see what that does. Well, gosh, isn't that crazy? All of these are doing the same exact thing. It's like a pattern here. It's algebraic patterns, and this is algebra, which is all about patterns. It's doing the same thing. Look at, when k is positive, it goes up. When k is negative, it goes down. Oh, let's check out this a. Let's see if this does it. Well, no, h first. If I'm right, and when I go to the left, it should go to the right. Oh, yep. So when h's are negatives, they go to the right, and when h's are positive, it goes to the left. Crazy, crazy. Okay, put that back there. And a. Now, if I'm right, it should like stretch it vertically, right? And it should flip it upside down when I go to negatives, and it should stretch it flatter when I'm between 0 and 1. So let's stretch it oh, there you go. Look at it. I'm stretching it vertically. See how it's going stretched vertically? It almost looks fatter in this one because it's just it's an optical illusion. But it's stretching it vertically, and then now I'm less than 1. Let's line these up just so we can compare them. Now I'm less than 1, and look at it, it's getting crushed down. Look at that getting crushed down. And oh, there's your 0 again. There's your flat line. And look at, and there it flips over. So it looks like the a, the h, and the k do the same thing as they did on the absolute value and the quadratic function. Let's just fill that in so we have it all. So just to fill it in, it looks like the a, if a is negative, it reflects over the x-axis. If it's greater than the absolute value 1, it's a vertical stretch. And if it's less than the absolute value of 1, it's a vertical compression. So that's what this a does again. The h, or what's underneath here, if h is negative, it translates right, and if h is positive, it translates left. And lastly, the k just moves it up and down. Up if it's positive, and down if it's negative. So now you can use these ideas. So you're going to see problems where I'm going to give you a function, right? Y equals the square root, or 2 square roots of x minus 3 plus 4. You're going to have to tell me what happens to that function from the parent function. Well, right at the back you say it was a vertical stretch of 2. It moved it to the right 3 and up 4. That would be how you would kind of state or talk about those things. So we'll work with more of those in class, but this is it. This is the notes right here. And yeah, have a great night, everyone.